My name is Michael Hilton and we're going to be doing some calculations for Lab 1. Okay, data tables 1 through 3 were basically just taking measurements. So data table 4 is really where we get into the calculations, and these are all density calculations from there for a few data tables. So we're going to take 3. I just randomly selected 3 calculations to do for density. Okay, so for data table 4 we have our liquid measurements. This was the liquid, and we were measuring water. The total volume was 5 milliliters. You can see the mass of the graduated cylinder 16.6. The mass of the graduated cylinder plus the liquid is 21.4. And so this is just the difference here, 4.8. Okay. Now the way that we calculate density is density equals mass divided by volume. So we take 4.8 grams, it's right here, divided by 5 milliliters, right here. So we get 0.96 grams per milliliter. Just below that for the alcohol, I've just shortened the data table right here. This is the volume, this is the difference, okay, and this is the density. So it's the same process. Take the mass divided by the volume, so it's 3.7 grams divided by 5 milliliters equals 0.74 grams per milliliter. So we go down a little bit to the displacement method. Same principle, the object's the magnet, okay? Same principle for calculating density is what I mean. The mass is 4.4 grams, and the final volume of the graduated cylinder minus the initial volume in milliliters is 0.9 milliliters. Calculate the density, mass over volume, so 4.4 grams divided by 0.9 milliliters equals 4.88 grams per milliliter. So that's 3 calculations for density. We're going to go ahead and go to the molarity calculations. Now, this was the 3 calculations I selected were from data table 9. This was the formula that we use. M1 times V1 equals M2 times V2. This is for finding molarity. M1 is the initial concentration, V1 is the volume transferred, V2 is the total volume, which in this case was 0.025 liters, and M2 is the final concentration. This is what we're solving for. Okay, so our first calculation, we're solving for the final concentration. We took the initial concentration molarity from the previous data table 8, and so just using some algebra, we've rearranged the equation here to M2 equals M1 times V1 over V2. So we just plug in the numbers. This is the initial concentration times the volume transferred, which was 2.5 milliliters or 0.0025 liters, divided by the total volume, 0.025 liters. That gives us this final concentration right here, 0.09659 molarity. And from here on out, it's just plug and play. M2, we plug in this initial concentration, which was the final concentration of our previous problem, times the volume transferred, in this case 0.0045 liters, divided by the total volume, gives you this concentration. That becomes our new initial concentration, plug in right here, times 0.003 liters transferred, divided by the total, which gives us this concentration right here. So that's 3 example calculations of density and molarity, and this is Michael Hilton for Lab 1.